This is question 6 on page 949. So it says, which of the following could be the remainders when 4 consecutive positive integers are each divided by 3? Okay, so a lot of you see right away that the best place to start is with the consecutive integers 3, 4, 5, and 6. Because when you divide 3 by 3, it goes in perfectly, so the remainder is 0. When you divide 4 by 3, it goes in perfectly one time and then gives you remainder 1. When you divide 5 by 3, it goes in perfectly one time and gives you remainder 2. I'm just going to quickly show what that looks like getting the remainder because I realize some of you might not remember this from way back when you first learned it. So 3 goes into 5 perfectly one time, and then you multiply 1 times 3 and bring that down here, and you subtract that from 5, so that gives you remainder 2. And then 3 goes into 6 perfectly, so it gives you remainder 0. And then this aligns with one of the answer choices, so it gives us D. If you weren't as lucky and didn't automatically come up with 3, 4, 5, and 6, let's just say you picked a different set of integers, and let's just see what happens. If you start with any multiple of 3, then it'll work out exactly the same. But let's say you weren't as lucky and you started with say 4. Then 4 divided by 3 would give you remainder 1. 5 divided by 3 would give you remainder 2. 6 divided by 3 would give you remainder 0. 7 divided by 3 would give you remainder 1. And then what I'd recommend is just continue to carry this out if you're at this stage, and then see if you can see any of these patterns here. So then I'd divide 8 by 3. So 3 would go into 8 2 times perfectly, and then you multiply these to get 6. So the remainder is 2. And then 9 divided by 3 gives you remainder 0. And now you're just looking and seeing if any of these patterns show up in this series here. And you'll see that the only pattern that shows up is right here again. So this is another way to go about this problem if you're not lucky and don't begin with a multiple of 3. You'll eventually get there as long as you carry the sequence out.